All right, hello everyone, this is Mr. Crozier. I'm going to go over problem 3 from our worksheet 4.2, area Riemann sums. We're given problems and we're told to do these 4 steps. So you'll see on my paper I have the problem, and then at the bottom I have the 4 steps that we're going to do. All right, problem number 3 gives us this function f of x is equal to 7 minus 0.5x over this interval. Well, first thing is that this problem can be written just like this problem right here. The interval is shown -3 to 3. This is the a value, this is the b value, that's the a value, that's the b value, and it's shown over this interval here, which is a function. We put a dx, and this is a problem, so these mean the same thing. All right, number 1, we're going to graph it. Let me get this set up on my calculator to graph. Y is equal to 7 minus 0.5x squared. Zoom 6 is the traditional 10 to 10 graph, and there we have it. It's an upside down parabola, hits at 7, and it hits over here 1, 2, 3, 4. So I'm going to put 7 there, 4 there, and it is this downward facing parabola. You want to make sure you take the time to find the intercepts. That's about 7 at the top. It's a little bit before 4 right there. All right, now what we need to do is shade it from -3 to 3. Well, your calculator will do that for you. If you hit second calc up here, this trace button, there is that integral button, number 7 right there. So you can go down to 7 or press 7, press enter, and type the lower limit, which is your a value, -3. Type your upper limit, which is your 3, and it shades all that area right there. So let's see here. There's my 3. Whoops, 3 is right there. 3 is right there. I'm going to shade in all this area. And that's what we're looking for. Now, the nice thing about this is your calculator also gives you the answer when it does this. It shades it and does the work for you. The answer here is 33. This area, if I were to find the area underneath that curve, we know what it is. It's 33. That is the answer to our integral. Everything we're doing for the rest of this paper is to get to this number 33. All right, so we have it on our calculator. We're ready to go. Next thing we're going to do is 4 right Riemann sums. Well, if I were to take this and divide this up into 4 sections, there's my 4 Riemann sums. And they're coming from the right, so they're looking like this, and this, and this, and this. But I have those points. So I have length 1 times width plus length 1, length 2 times width plus length 3 times width plus length 4 times width. There's my 4 rectangles. Well, what is the width of this rectangle? Well, the width of a rectangle is another name for dx. And if you look on your paper, right down here, it tells you how to find dx. You take b minus a divided by the number of rectangles you have. So I have 3 minus -3 divided by 4 is 6/4, which is 1.5. So when I make these rectangles here, every step is 1.5, 1.5, 1.5, 1.5, 1.5. And that should make sense because if you have 4 1.5s, you have your interval of 6. It's 6 from here to here. All right, so how do I write that? Well, I know what the width is. The width is 1.5. But what is the length? Well, the length here, you have to be careful. I'm going to do the function value. Watch where this is starting at. This is starting at -3. And then I'm going to add on to that 1.5. So I have f of -1.5 plus another 1.5. And now I'm going to add on what? I'm at -1.5 right there, and I add on 1.5. Now I'm at 0. Plus another width of 1.5. If I add on 1.5, now I'm up to 1.5. And the last one, same width, But where am I at now? Well, I'm at this endpoint, so I'm at f of 3. So I have those values there. Those are my 4 points. Those are the coordinates of this point, this point, this point, and that point. Those are all those coordinates. Let me show you how to do that on a calculator. If I have my function in here, there it is. If I set up my table to ask for the inputs, let me delete all these. My first value is going to be at, I can type this in here, -3 plus 1.5 at -1.5. Now I have my next value is at -1.5 plus another 1.5. I'm there. Then my next value is at 0 plus 1.5. And my last value is 1.5 plus another 1.5, which is 2.5. Whoops. I typed that. Oh, it's 3 right there. So those are all my inputs. Those are my 4 values here. -1.5, 0, 1.5, and 3. And there's all the outputs. Watch the math I do. All of these have the same width, so I'm going to factor that out to the front. And now I'm going to put these outputs in there. 5.875 plus 7 plus 5.875 plus 2.5. Let's make sure that looks right on the graph. Watch these points. It's at 5, 7, 5, 2. It goes up, then down. You can't, I don't have a great graph here, but that's what's going on. It's going up, then down. All right, let's finish this math here. If I add those up, 5.875 plus 7 plus 5.875 plus 2.5, 21.25 times the 1.5, which is my width, 31.875, which again, it's close to that number up here. Again, this is my answer. My answer is 33. I did these Riemann sums and I got close. All right, let's try and do the Riemann sums for all of them. However, let's jump down to our table for a second. The table is the table of area. For the number of rectangles as an input, area as an output. We already know what this is. If I do 4 rectangles, I have 31.875. And I already know what happens if I do an infinite number of rectangles. Well, if I do an infinite number, I get the exact answer. This goes into 33. So what I'm going to do now is a little bit of calculus here. Is I'm going to start with 4 rectangles, then go 8, 12, 20, 100, 500. I'm going to keep getting closer and closer and closer and closer. And that is the idea of a limit here. If I increase these, I can get closer to this value of 33. So we need a formula, because this is